Great. Thanks and good afternoon. We're gonna try and do this not in 15 minutes, but in 10 minutes because we're in the enviable position between you and a brownie. So we want to make sure everyone can get a snack. I think that where we're going to start is picking up off of the very first talk from Jerry and Nicola, which is this concept that in the spectrum of AI, there's these fantastical ideas of AI, but then there's just about simply making software better and smarter. And we have this unique challenge at Salesforce where we manage hundreds of thousands of customers, and whether those customers are selling forks or forklifts, we have to build solutions that work for both of those two customers. And so I thought there was no one better. We looked across our org, and I thought there was no one better than Leah to come talk about this challenge, because at the end of the day, when we think about AI, the thing that drives all of this intelligence is the data that our algorithms will learn from. And Salesforce, as a repository for so much customer data, is a really exciting place for AI problems to be solved out. But they also present one really unique challenge, which is that our number one value as an enterprise vendor is trust and privacy. So we actually can't do what we normally would do with the data that normal data scientists would. So why don't we start there? What do you do day in, day out when you build a model? How does that change when you go to enterprise?
Well, I think the big thing that's different is when you think of in a B2C setting where you're building a model, essentially the data scientists will go in, they'll sort of look at the data, they might download a subset of the data to play with on their computer, right? And then they sort of look at different features and decide, oh, these things are probably really important for the model I'm going to build. They might do some text processing, they might normalize things, just change the features, and that's a big part of it. Then they may decide on the perfect model that's going to do this, test out a couple of hyperparameters, figure out what's going to work, like even on a local small batch, and then just deploy that. And that works on the larger sample. But when you're dealing with Salesforce, that doesn't scale to 100,000 customers, right? You don't have 100,000 data scientists who could do that. And even if you could find that many data scientists, you can't be downloading the customer's data to look at it and build models. And so what we found is that you have to do, meta machine learning. So you have to take a particular application and then sort of decide, okay, I'm going to try and model this type of problem, and I will do it with feature engineering based on the Salesforce data types. So Salesforce has rich feature types like email or phone number, and so based on those types, I will incorporate information and do appropriate transformations. And based on the type of problem that I'm trying to solve, I will test many different models for each customer and determine the best model, determine the best hyperparameters. And so you're sort of automating a lot of what a data scientist would do in order to avoid this conflict of you don't have enough data scientists in the world to actually build custom models for every single company.
Great. So when we think about that, or when you think about that, there's also this context of thinking about it like locally to a single customer versus globally across all customers. And how do you think about balancing what's the right approach to take? Because forks and forklifts, again, not everyone has the same business.
It's definitely a challenge, and I remember in one of our early models, we were trying to figure out what was going on when we had modeled clicks on emails, and then our models were failing because we had assumed that click-through rate would be very small. Like most companies have 3% click-through rate, that's pretty typical, or less. And then there was one company who we were doing a beta on, and they had 30% click-through, and it just broke everything, right? And so part of it is building elasticity into the model. So if you're doing a particular technique, then you need to do sampling on the data, make sure that technique is correct before you apply it. And so the really big part for building sort of the across customer models is you think about everything that you might apply for an individual customer, and then find a way to automate that check for it to work across many different customers.
Great. So, the story Einstein kind of came out of nowhere last year, and for those of you that were at Dreamforce, you probably saw Mark introduce it. But You've been working on this problem for almost 2 years now.
Almost 3, actually.
Almost 3. And then last year we acquired $700 million worth of friends to help you. What's that, like, how does that scale process go where you're starting to all of a sudden pull in new teams and bring new technologies together into one system?
Right. It's been really exciting. So, yeah, when I started out, we were actually a group of like 5 data scientists working in the basement in Palo Alto. And then since then, I mean, there's just all kinds of companies that we've acquired, and some of which we're working directly with them, and they're like wonderful engineers from Prediction.io who have joined our team. And other thing is like just amazing technologies and sort of figuring out, okay, so if we're going to support all of these different types of models, all of these different stacks, what do we need to build to make it basically easy for all of these really smart people to build products on Salesforce, to make it sort of a smooth process so that they don't have to go and duplicate, data pulling, data pushing, ETL services, anything like that, which no one wants to do, but it's a huge part of actually building intelligent systems. So.
Yeah, I think in participating in a lot of your team's conversations, there's always this trade-off of build the feature or build the platform to build the feature, and which one's going to scale. As long as, I think as long as we're thinking future-minded, we always have to like build a platform. But I think conversely, we've also been very focused at trying to solve exact problems. And maybe we can just pivot to like what are some of the core problems inside of Salesforce that we're trying to solve right now, versus trying to solve the whole ecosystem of the CRM lifecycle.
Right. So I think that's the big one that was announced at Dreamforce was of course lead scoring, because it's huge. It's Salesforce core. Of course, predictive journeys, and I don't know. I shouldn't talk about things that we're doing right now, probably, but.
Well, you can talk about commerce. So in commerce, predictive recommendations on products.
Opportunity insights as well. And so I guess part of the challenge with with Einstein has been that we're building the airplane while we're flying it. So we are building apps on top of the platform while we build the apps, or the platform to support the apps. Which has been a very exciting experience. And so far it's actually worked out pretty well because we stress test as we go. So, go GA with one app and make sure that the platform can actually support that. It's been exciting.
Exciting is a euphemism, I would say. So a lot of people here in this room are probably looking at either investing in startups or they're working at startups around AI, and as we've built Einstein, your partner in crime who's not here is Carl on the engineering side. And we've learned a lot about what it takes to do the engineering side of the house for this kind of data. What are some of the generalized learnings that you think you've seen Carl go through?
Well, there's a lot. I mean, the trust aspect is of course huge, trying to figure out how to build a system that data scientists can actually work in while still maintaining trust with their customers. It's an incredibly complex system to manage. So like just all of the services that we need in order to manage what data is there, when it's being used, like which models are in production, when those models are good enough, is incredible. So.
I think the number one thing that we get on the commercial side is immediately where is the data going, how long is it there? Like, selling into the enterprise opens this can of worms that we don't have when we do a Google search or when we use Facebook. We don't really ask where that data is going. But the minute you're telling someone that you're going to take your data and learn from it, that's when you open a whole can of worms that forces us to be a lot more thoughtful on the engineering side.
Right. And it's also making sure, so one of the huge things is instrumenting every single step of that, right? So because you can't go in and if something isn't working, you can't look at the data to try and figure out why. So you have to have it really well instrumented that every step was completed successfully, that it met the requirements, so that you have these automated checks, that there's no one going in and looking at proprietary information at any point. So.
Great. So I wanted to keep our promise and keep this short, but I also wanted to let you guys ask a question or two. Does anybody have a question? Oh, a handful of questions. See, I thought this was going to be a good idea.
Very good presentation. So a lot of the larger companies are now in a race to create AI platforms. Google, you guys, Microsoft. So I was wondering what you're trying to achieve through your partnership with IBM through Watson. So what does Watson give that Einstein does not have?
Sure. So I think that when we look at, this goes back to sort of that initial statement of like the data is the key partner to algorithms. When we look at Watson has built phenomenal AI models, but they in many places they don't have the right data sets for CRM. And we are hyper focused that Einstein is AI for CRM. And the approach that we've taken with that is really by taking the stuff that Leah's working on and pointing it where we know the customer data already is, and where we don't need data scientists or Accenture or any of our partners to turn it on. Literally, you just turn on something like lead scoring, learns from the data, gives you your lead score. The challenge is as we go and talk to our large enterprise customers, they say, well, I'm really interested in learning from this data, but I also have been running IBM for the last 20 years, and I want to learn from that data too, but we're never going to move that data off of IBM. And so this partnership is as much about where the data is residenced as it is everything else. And then IBM also has a really phenomenal, interesting data set that we are interested in, which is the weather data. You know, they bought weather.com. And so there's a lot of, in the selling markets, there's a lot of, well, how is the weather going to affect selling? So that's kind of how, that's a high level of where that partnership works. Sure.
Thanks. So the question is, you mentioned 2 or 3 times that you have a data proprietary issue with using your customer's data. So have you thought about acquiring some kind of either consumer or enterprise, your own enterprise data to do the same without having to use the customer's data?
Well, I think if we didn't use our customer, I mean, Leah, why don't you get to that?
Yeah, I mean, the thing is that the customers basically they put their data in Salesforce for a reason, right? Like they think this data is very valuable, and they want Salesforce to tell it more about it. So the customer ask is really just like, make this data work more for me, not tell me other things about my industry, right? They really want to have, like, they may want the value add of other information about their industry, and we do look at external data sets as well. But really what they want is, given that I am telling you, who I might contact for sales, who should I focus on? Like, they want that added bump to the Salesforce experience more than anything else.
What she said. Any other questions? We've got about time for one last question. Okay. Oh, just in time.
I'll just call it out. On a follow-up to that, can you give us guidance? How much data does it take to build good AI?
So it really depends on the question that you're trying to ask and the quality of the data. So there are things like we can, if a company tracks their leads very well and really fills in lots of fields, then we can predict leads with a very small number of actual entries, right?
Small being 100, small being 1,000.
Small being 1,000. But if, for instance, none of the salespeople are actually filling in the leads as they go, they're just filling them in at the end, we may not be able to do as well predicting them. So part of it is how good the data entered into Salesforce is. So it's sort of this carrot, like if you use this properly, we'll give you insights into your data, but you have to like actually fill it out before you close the deal. And part of it is sort of the field. So deep learning obviously applies to different kinds of questions and requires more data, but then you can leverage pre-trained models or externally trained models. So there are a lot of tricks to make it work better with smaller data sets. But in general, it's highly dependent on the question that you want to ask and how good the data going in is.
And I'll just add, like from a commercial point of view, we found that hooking in things like email, website, those are like natural sources of data that's related to the CRM ecosystem that kind of self-populate through the enterprise. So if someone's going to a certain product page, that's giving us lead data. We're getting all the sales reps email and automatically logging that in. We can learn from all the conversations and use NLP on all those conversations, identify trends there. So what we're trying to also do is like make it so that people don't have to think about where their data is, it just kind of flows in. So with that,
Thank you, Leah.
Thank you.
Jim. We'll take a break till 4 o'clock. There's coffee, tea, brownies, cookies. Thank you.